video, we are going to talk about section 4.1a, which we'll start discussing a discrete probability function. And even though that might sound a little different and new, it's going to be quite repetitive of things we've talked about before. We're just kind of focusing on some new notation and new vocabulary to set us up for success for the rest of the course. And so even though we won't really use this too much until the next chapter, which is after the test, it's still just good to talk about in this unit because it has to do with probability. So let's get this started. All right, so we have 4.1a and a discrete probability density function. You're going to notice right off the bat has the same rules as the probability that we've been talking about. So you'll see right here, it says that each individual probability is between 0 and 1, and the sum of all the probabilities is equal to 1. And I know I always say that this is super important, but it is super important. And at every time we add a new layer of this, we always will come back to these rules. So you have to make sure that you know both of these rules, because if you're not following one of them, it's going to mess up the problem. Okay, so this first one, we have a probability density function, and we want to find the probability that x equals 1. So as a reminder, this first row, the x, that's the data values, and then the second row is the probability of that specific item. So this is the probability that x equals 1. So there's two different ways you might see this notation. So I'm just going to write them underneath. You could see the probability that x equals 1. It has two equal signs. I didn't invent it. This is what I like. I like the probability of 1, but Newton kind of flip-flops back and forth, so I just want to make sure you're familiar with both. All right, either way, in either situation, we're looking right here. This is where x equals 1 because it's in the x row. So the probability that x equals 1, we can see right here, is 0.25. I watched one of the last, what did I do? I think I hit the keyboard with my arm, so I'm just going to move it real quick. I watched the last video and I was like, golly, this pen is really big, thick. It's because my tablet is really tiny that anyway, I'll fix it for a future video. One of these days you'll be surprised. I'll remember. Oh my gosh. Okay, here we are. So it says a pair of fair dice is rolled and the sum of their faces is recorded. So anytime it says fair dice, you're allowed to assume that it's six-sided. If it is more than 6 sides, then you can just, it'll tell you what I'm trying to say. All right, the probabilities of each sum are recorded. So before we do this problem, let's think about what it's saying. And I really want to go into detail with this one because we're going to see this example coming up a few more times, I think in the next video. Okay, so we roll 2 dice. One, let's just start at the beginning. We could have a 1, so this is my dice, a 1 and a 1. So if I add that up, it equals 2 because it says the sum. I could have a 1 and a 2. That equals 3. But I could also have a 2 and a 1, and that equals 3. And I kind of did them in the same color, but let's just pretend this first one is actually, we'll make it red. The first one is red. And so that is why these two are different, because one of them has the red as 1 and the blue is 2, and the other one has the red as 2 and the blue is 1. So those are different scenarios. And so if we did all of these, all possibilities, there's 36 possibilities. And that's just, we could figure it out because there's 6 possibilities for one, 6 possibilities the other, and we multiply and that equals 36. But if you don't know that rule, that's fine. Just know that there's 36 possibilities because we need that fact for the rest of this problem. Okay, so what this is saying is the probability that the sum is a 2 is 1 out of 36 because there is just this one scenario where we get 2. 1 plus 1 is the only way to get 2 from dice. Then for threes, there's actually 2 scenarios, right? The first one and the second one here. And so this is 2 out of 36, which is where the 1 over 18 comes. And if you are not a fraction-y person, you just do 2 out of 36 on your calculator. There we go, 1 out of 18. And so forth. This one is 3 out of 36. 4 out of 36. This one can't reduce, so we see 5 out of 36, 6 out of 36, and then notice the pattern goes back down. 5, 4, 3, 2, 1 out of 36. Okay, that has nothing to do with this problem. I just wanted you to start noticing some patterns because we will talk about this specific example multiple times because dice and cards are super common in probability. In fact, the rest of the course. Okay, so what is the probability that the sum of the faces is 4? So here's 4 right here. The probability that we're going to get a 4 is 1 out of 12. And that's it. We're reading, we're reading this table the same way we've been reading other probability tables. We're just calling it the probability density function. Okay, which sum is most likely? So this would be the biggest probability. Which sum is least likely? This would be the smallest probability. So which one is the biggest probability? That would be the middle. So that would be 7, is the most likely, because there's so many ways to get a 7. There's 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Okay, what's the smallest probability? Well, that's either going to be the 2 or the 12. And the reason is there's only one way to make a 2, which we talked about, 1 and 1. And there's only one way to make a 12, which would be 6 and 6. So those two have the smallest probability. Remember when we were in math, we don't care about English rules. So when it says which sum is least likely, like it kind of sounds like they're talking about one answer, but we have two answers. It just is the way it is because they tied. Okay, so here we have an incomplete probability density function. And it says the number of pets per household is listed below, 0, 1, 2, all so forth. And we have this missing probability of 4. So what we want to do is we know that all of them added together has to equal 1 because that is just one of our core rules of probability. So I look at what I have here. I go over to my calculator and I type in 0.72. Oopsies, I forgot the plus sign. All right, 0.72 plus 0.02, 0.13 plus 0.11, and I get, oh, this is real tiny, 0.98. The nice thing about all of these adding up to 1 is that you're very familiar with 100 and $1 and all that stuff. So we don't really have to do too much in the calculator. Once we know that this adds up to 98, well, we know from money that there has to be 2 cents left. So this box right here is going to be 1 minus the 98 that we already accounted for. If that isn't super obvious, if you don't know how to do it, because I mean, it's always going to be 98, right? Like sometimes it's going to be a little harder to calculate. Just come over to your calculator, 1 minus, and then you just type answer. You want the answer from before, and there we go, 0.02. Okay, so now this is really about practicing the core rules of this section. So this is saying which one shows a valid probability function. And it's been like 5 seconds since I talked about this, so let's write it down again. We know that the sum of all the probabilities has to equal 1. And we know that each individual probability has to be between 0 and 1. So no negatives, no numbers bigger than 1. So I like to start with that second rule first, just because it's usually easier to see. If I see like this guy right here, this guy has a negative. I'll just write this over. Note this right here is negative. So it doesn't matter. Anything else doesn't matter. It's negative. It's wrong. Okay, oopsies. Let's look. Any other negatives? No. Any individual numbers greater than 1? No. So there's nothing else super obvious. So now I will start adding things up. So I go to the first one and I type in 1/4. Remember to hit over when you hit plus, so it's plus is in the bottom. 3/8. Oh, what did I just say? And then I did it. 3/8. 1. So there's no zero. There's no negatives. There's no nothing greater than 1, and everything adds up to 1. That one's perfect. Okay, this next one, 0 is allowed because it says it has to be less than or equal to. It has that or equal to over here. So 0 is allowed. However, as soon as I see 70 cents plus 50 cents, I'm even just rounding down and I see that it's too big because 74 plus 54 is greater than 100. So this one is the sum was greater than 1. Can't count, can't have that. Okay, next one we have, and we're just going to keep adding these until we figure out all of them because that's the second step. So we have 0.18, 0.76, 0.06, 1, perfect. Let's see, 1/8. Where's my calculator? I wonder if I could touch on my tablet. 1. Okay, well I can, but it's not very fast. I'll use my keyboard. 1/8 plus 1/8 plus 3/4. I'm hoping you're using this calculator on your phone. Like you got the app, it's free, and following along. If you're using it on your computer, that I don't care. But you just have to bebop back and forth between screens, like when you're taking the test. So it's a lot easier to have your phone and have the app going, and then do the test or quiz. Okay, this adds up to 1. Perfect. Uh-oh, I switched. There we go. And then last but not least, we have 1/10, 1/5. I see it. 1/10, 1. Whenever I say be careful, like be careful you move it over, it's because I do it all the time. It's not because I think that you don't know how to do it. It's because I do it all the time. All right, 9/10. The sum of the probabilities was less than 1, so it goes in the trash. So that's how you show something is a valid probability function. Now, let's talk about combining probabilities. I can't remember if I mentioned this in chapter 3, but we're not getting super deep into probabilities, just a lot of the basics, the 2 main rules, and then a lot of like combining probabilities by adding. So here, I'll use the highlight here. We have a discrete probability function. Great, we don't have to check it. It tells us it is. What's the probability that x equals 1, x equals 2, or x equals 4? So when we're trying to figure this out, we're figuring out the probability of 1 plus the probability of 2 plus the probability of 4. So that's 1/20 plus 7/20 plus 1/10. And as a reminder, you always want the answer as a reduced fraction. Well, when it's a fraction, you want to make sure it's reduced, and that shouldn't be too much of a step because as soon as you put it in your calculator, it'll only give it to you reduced. It won't give it to you. Let it be unreduced. Then I didn't even put plus signs this time. Goodness gracious. I wish you could see how tiny this is. So that's why I'm squinting. Okay, 1/2. Voila. So the probability of those 3 added together is 1/2. All right, last one. So this says this shows a probability density function. So again, we don't have to check it because it says it already is. The number of cups of coffee. So first, what is the probability that x is less than 3? Okay, less than 3 is the probability of 0, 1, and 2. That is what less than 3 is. So that would be these 3. So we have 1/8, 3/16, and 3/8. Less than, it doesn't say less than or equal to, so we can't include 3. So we have 1/8, 3/16, and 3/8, and we get 11/16. So the probability that x is less than 3, which is the same thing as saying the probability of 0 plus the probability of 1 plus the probability of 2 is equal to 11/16. We're going to be doing a lot of this in we're in chapter 4, next week, chapter 4.2. All right, what is the probability that x is greater than 3? So the probability that x is greater than 3, again, it doesn't say greater than or equal to. So we only want the probability of 4 and the probability of 5. So that's going to be 1/8 plus 1/8, 2/8. 2/8 equals 1/4. Voila. And finally, what is the probability that x equals 3? That one's the easiest one of all because it just is asking for that single probability. We don't have to add anything. 1/16. Okay, so this was just kind of a summary of everything you never wanted to know about probability. This is, let me find one so I can get big again. This is, I don't know, I got big and I didn't even know what I was going to say. So I guess I will see you in the next video. Email me if you have any questions. Bye.